Lo può provare a parlare un attimo?
Mi sentite?
Aspetta un attimo. Riprova.
Mi senti?
Sì, sì, ti sentiamo. Aspetta.
Ok.
No, sì, sì. Riprova ora.
Mi senti?
Sì, 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 ok.
Perfetto. Lo schermo non si vede però, dovete riattivare la condivisione.
Arriva. Registrazione cominciata.
Sì.
Ok. Alba.
Ladies and gentlemen, welcome again. I have now a microphone. It's time for songs. Who will be the first? I want to party for 10 minutes. Alba, who will be the first? Already a bit.
No, I'm so bad at singing. No way. I love you so much, all of you. No.
Okay. Can you hear me correctly? Yes. Yes, thank you. Andrea gave me 2 hours, but I think that we realize my summary, my last 80 hours, 80 slides prepared for you for the next 1 hour. Just to know, for 35 minutes we'll create a break, and at 5 o'clock we will finalize anything I have. For you, we have enough time for questions, etc. Now let's speak about the logical threats from the point of view, and for the beginning, I have one question for you, just to see. Andrea told everything is okay, but nothing except. Oh, I know why. There is.
Let me see, maybe he didn't put the.
This is not inside. It's not.
It's on, yes. There should be a pen drive.
There is.
Just wait one more time.
Okay, sorry. Thank you. Okay, my question for you. Can salt be radioactive? What do you think? You already use salt in our homes every day. Someone on bigger amounts, someone with smaller amounts. Yes, the answer is yes. But how to know it? If salt contains radioactive isotopes of elements, for example, potassium or radium, and when you buy someone, you probably tried to use Himalayan salt. In this Himalayan salt, in my laboratories, especially the samples from Pakistan, this red color is from iron oxide. Inside this material, we find traces of radioactive elements. You don't use big amounts, etc. But don't want to be curious and to buy, for example, specific products from specific regions to be sure not to insert many radioactive elements in your body. Also, for many laboratory activities in our institutions, research institutions, military academies, especially, we'll use the salt substitute, potassium chloride, and this salt has natural radioactivity according to amount of potassium inside. It's potassium 40, it's beta gamma radioactive emitter. The RDD, radiological dispersal device, we spoke about construction principle, explosive and radioactive elements, radioactive material inside. If you put this type of cesium chloride salt, C47 salt, combined with explosive, you will create a very efficient dirty bomb. Dispersion of this material will cause extensive disruption, psychological effect, psychological harm, and environmental damage. You can say ordinary salt, but you have all consequences after usage of dirty bomb radiological dispersal device. Also, from the primary school about radium, just to summarize basic chemical and physical characteristics. Radium is the 6th element in second group of the periodic table. Radium chloride was discovered by Marie and Pierre Curie in 1898. All isotopes of radium are radioactive, and the most stable is radium 2226, with half-life of 1,600 years. You know what is the half-life in the area? What can you describe half-life of some radioactive element? What is that? What is that time? Half-life is?
It's the time where the emission of the radiation is a halt.
50% of that. And you need 1,600 years is much more time for one generation, you know. And very interesting for radium, the scientists in that period found that during that decade, this element emits ionizing radiation, and we have radioluminescence. What is radioluminescence? Some specific lighting, especially in the dark. And many people try to find the solution for, you know, in the army, in the warfare, you need to see correctly. And during the night, if you're a pilot, you need instruments, and you need luminous specific color. With radium inside, you will have excellent brightness in the dark. Also, the radium was used as standard radium solution preparation, and you can see many interesting products for that period of time. You can see bottles, standard radium solution for drinking, for many problems. You can see here different problem, chronic joint diseases, muscular pains, rheumatism, etc., etc. And many people drink radioactive elements to feel better. Also, different compresses and bandages with that different ampoules of this radioactive element. And this is very interesting story. From my point of view, Andrea told you about your thesis, about your seminars. This is a very interesting topic for exploration, for analysis of radiographs. Many people doesn't know anything about radiographs. In that period of time, it was the female factory workers. All of them were very young girls, around 20 years ago. The factory paid them much better salaries on a daily level, and their duty was to paint radium dials for different devices, for trucks, for airplanes, for helicopters, and it was very delicate because they use very small painting, very brushes, small brushes. You can see all that process, but very often they use their lips, they don't salivation product because they told it was very precise for painting. But in that case, they insert big amounts of radium inside, and the consequences are really very harmful for all of them. Yesterday, I told you about this radiological incident which was happened in Brazil, Guyana, in September 1987. It was very interesting event because area of contamination was, you can see, 4 million square meters with 249 contaminated persons with cesium 137, 129 people with internal contamination, and 4 dead. How that started? Because somebody steal this source of contamination, because cesium 137, from teletherapy machine in abandoned clinic, in scrap yard. And remember, I told you, we are curious. We found something which was very bright, shining, interesting. We think just how to use on a proper way, but it's very highly radioactive material, and in that the consequences where you can see health effects of people if you hand this material. If you use this material in your hand, you will have skin burns or different areas, even tongue, throat, etc. London 2006, you probably heard about Alexander Litvinenko, former officer of the Russian Federal Security Service and KGB agent. He said that they were ordered to kill Boris Berezovsky, Russian businessman, in 1998, and the Russian government began to persecute Litvinenko. He was in UK later, criticized Russian President Vladimir Putin, and on November the 1st, 2006, Litvinenko was poisoned by polonium-210 added to his cup of tea. Now we have evidences, we know results, chemical and biological analysis from his organism, etc. He died on November 23rd. Just analyze how many days after the contamination, 22, 23 days, 3 weeks after the contamination, internal contamination. Why? This is classical acute radiation syndrome. You know difference between alpha, beta, and gamma rays. Yeah. There are probably many of you. We will have lectures later about that. What is physically alpha ray? It's yes. Yeah. And what is the distance of this small particle? Very small, up to probably 10 centimeters. And from alpha radiation, even ordinary paper can protect you. And you're safe at 10 centimeters and more distance. But what will be if you drink alpha particle in tea, coffee, water? You will have internal processes, constant immediate reaction with your tissue, constant irradiation of your body, and for 3 weeks, in this case, late time. Here you can see pictures, original pictures of his hospital treatment. And one very interesting technical fact that I prepared for you, just to know, 1 gram of polonium is enough, sufficient to kill human person. Just 1 gram. It's a really, really small amount of. After entering the bloodstream, polonium goes to liver, kidneys, along with the bone marrow. You know how much the bone marrow is important for us for the production of blood cells, red blood cells. He was initially admitted to hospital with many diarrhea, vomiting problems. His skin turned yellow. It's not a perfect lamp of the projector, but on a computer you will see he's really, really yellow. And when you see the yellow skin, you know that someone has a problem with liver, hepatitis or something else, of course. And for terrorists, it's so important to know that polonium, if you add to tea, to water, is tasteless. You cannot find that you are contaminated, that you drink something wrong. Even if you use some kind of detector, it's very difficult to find that you are contaminated. Very interesting story for Germany, 2008. It's very common type of contamination. That's cobalt-60 contaminated stainless steel. You know that we stainless steel used everywhere in the kitchen for knives, for plates, for cups, for many usages. And in this situation, in the big European harbor transit area in Germany, in Hamburg, the German police inspectors found container with full container with cobalt-60 contaminated steel. They analyzed the origin. The material was transported from India. Destination was Russia, and material was returned to sender. Next appearance the same year, cobalt-60 contaminated elevators buttons. If you use it elevator, everybody will be contaminated somehow, even small kids or old elder people, of course. It was a supplier from France, and these buttons was found in France, Italy, I don't know where, and Germany. Also originally material from India, produced in India, but buttons were replaced everywhere according to materials and documents I read in the past period. Also, different stainless steel cuttings they found in German scrapyard, originally from India, and also this material was returned to sender. In that case, in that period, in 2008, in Germany, German scientists and German police inspectors started to thinking on a higher level how to protect country from radioactive contaminated material, and the main purpose was to install different checking barriers, detectors, everywhere, specific borders according to transit area, countries, etc. And you can see how this border looks like. For example, in my country, if you want to go to Nuclear Institute, when you pass pedestrian gate and control, if you travel by car, there is normally two detectors. You will pass, and the detector constantly measure the level of radiation, just to be sure that you don't enter nothing into the institute and nothing from the institute. Inside is a X-ray source, and it's possible to scan everything inside. Now it's normally installed in every customs, in every borders for the trucks, etc. But sometimes If we speak about hiding something, if we speak about, for example, migrants, there is a problem. This is a picture originally from Texas, Kingsville Border Patrol Station. I mean, we can really see how many people are inside. And what about the dose of radioactivity? It's much more than screening of the lungs, much more than examination liver or something else. Full body scanning, and it's very harmful for human organism. But there are many cases really all over the world. Probably in Italy, I know from Hungary. Hungary is northern than my country at the border because of the, many people try to run away, escape from many countries, even from Syria from the beginning, and at the beginning of the war, so the different countries. India, Mayapuri, very important accident in April 210, radiological incident. In this case, the medical instrument is also very important for us. It's gamma irradiator with gamma cell inside with small pencils. It was placed in scrap market on Mayapuri, and somebody tried to steal something. They steal 16 cobalt 60 pencils. Each pencil had 7 slugs of the radioactive source. The radioactivity is very big level. You can see at 1 centimeter from unshielded single pencil, 75 grays per hour. And I will show you a table how much is that. It's a very big dose, very big amount of radioactivity, very harmful for human. 1 person died, 7 with really big injuries on the skin, and that was a really big problem. Mexico, April 2015, Tabasco, truck was carrying a container of iridium 192, highly radioactive material used in industrial radiography. Industrial radiography is also important because in the production you need to find all malfunctions and problems in structure of metals and the other elements, and this device was stolen. And Operation Cobalt Delphi, and improvised nuclear devices and dirty bombs. Just few sentences. My question for yesterday was, is it easy to obtain, to find radioactive material? And we spoke, somebody told me, yes, we have smoke detectors at the stadium. Is it possible to find some radioactive elements somewhere else? What do you think?
The hospital.
In the hospital, in all many medical instruments, yes, for the radiography. Also, what do you think? Airports, yes, in the safety check controls. Industrial, yes, industrial tracks, as I told you, for measuring of the level of some fillings, bottles, waters, yes.
Also for control.
Yes. What do you think?
Alimentary.
What do you think about the usage of radioactivity for disinfection? What do you think?
Alimentary include this.
In many countries, it's obligatory. It's necessary according to rules. For example, when Serbia my country import spices from India, pepper, some other spices, it's necessary to use and to put all amount of spices into specific chamber with radioactive sources, because radioactivity will destroy all animals, because they're animals in brackets, all microorganisms, all molds, everything inside, but the taste will stay the same, and there will be no secondary irradiation of these spices, etc. And that's normal process. Just to know, food irradiation is very important and present in many countries as preventive measure to protect us from everything. But from terrorist group or someone who wants to disturb us, they all the time think to create something like improvised nuclear device, radiological dispersal device, dirty bomb, and we must be prepared. You know that improvised nuclear device involves nuclear material, also needs to have explosive inside and to be able to disperse this big amount of radiation all over the time. Here we can see some attempt. Methods of trafficking, you recognize these Pringles, yes, potato chips. This is very interesting bags. Smuggling is first method of trafficking. Concealing radioactive materials in personal belongings, luggage, cargo shipments. This was one attempt with some passenger wanted to hide to smuggle something, but police found it at the border and it was successful for him. He's in jail even now. Theft means stealing radioactive materials from secure facilities or during transportation. I have many interesting facts and scenarios for you during the next slides. And black market sales, you know, you have different internet pages, protected or unprotected for black markets, and it's possible to find many strange things, even radioactive materials as a result of trafficking. Here we can see people who are trained at the borders, and they use some handheld radiological detectors to find sources of radiation. But many times, in many countries, we use something automatically designed, bigger gates, it's faster, it's full scanning, because if you want to scan something on the high point, you need to use ladders, or that in that situation, it's a risk for him. We know what is the hazard and probability, likelihood. One interesting example, USA, Wilmington, 1979, the worker in this General Electric nuclear plant company bypassed several layers of security, and he successfully stole two almost 20 liters cans of low enriched uranium dioxide. Successful activities against control, against the gates and the control system, and materials were discovered 4 days later. Russia, 1992, Leonid Smirnov, he was technician in the nuclear facility, stole 1.5 kilo of high enriched uranium during 6 months. Slow amounts every day in glass bottle, and you can see 60 grams every day for a few months. He collected 1.5 kilo, but his plan was to how to transport to some end user, and he used baggage locker in the local railway station for a long-term storage. But somehow with radiological detector moving there, detector goes crazy, and they found him. In the other case, it will be very good activity, very professional activity for this theft. Lithuania, 1992, multiple insiders in Galina nuclear power and power plant also had idea to steal an entire low enriched uranium fuel. Absolutely, and they found many of the material, but some of the material they didn't find even now. Germany, 1994, 3 passengers from Russia were arrested in the airport in Munich. This was a flight of Lufthansa to Moscow, and they found 363 grams of plutonium. They were sentenced for 3 to 5 years into the prison. Also in Prague, Czech Republic, police arrested individuals with 2.7 kilos of high enriched uranium. Moscow, 1995, Russia, group of Chechen rebels, they called Russian TV station and told them, Ismailovsky Park, go there, you will find yellow bag, inside is some kind of radioactive materials, and absolutely they found their partially buried container of radioactive cesium. I don't know what are they, but what was their intention, because they called police and tell them what is there, which amount, and that's very strange information. But for me, USA, 1998, Greensboro, North Carolina, small tubes of radioactive cesium stolen from hospital, very sensitive, very powerful, but they never found this radioactive element, even now. This is also information from Argun, from Chechen Republic, container full of radioactive material, find near a railway line, safely diffused, and they bring it to safe place. Chicago, Illinois, 2002, Jose Padilla, US citizen, they have told that he has a connection with Al-Qaeda, arrested in Chicago airport on suspicion of planning to build a detonate dirty bomb. Herat, Afghanistan. Pictures of different radiological dispersal devices. You can see doses, cobalt inside, etc. According to relevant information, Al Qaeda is responsible for this organization. Very interesting facts from London, 2004. Islamic terrorist cell stole household smoke detectors. I told you, each detector has a small radioactive material. You know the size of this diameter of this device or detector, we can say 10 to 15 centimeters. This area, we see the warning sign, contains americium 241 or californium 252. Small amount of radioactive element because we need constant ionization of the air, because when the gas or fire smoke comes inside, we have a penetration of signal and we have a very strong alarm. But the main problem is because of the physical and chemical characteristic of that americium. For example, you can see 400 years is half-life. It's very persistent element. And biological consequences, you can see this material, this radioactive element will stay in human bones for 15 years and 20 years in liver, if you can live much more. Georgia, 2006. Individuals try to smuggle different material, but every time it's also the same. High enriched uranium across the border from Russia. It was 100 grams of this material. Moldova, 2011, 1 kilo of highly enriched uranium. Also different packages, different approaches. Romania, 2013, also it was uranium 235 with international agency Interpol successfully organized. And this is very interesting to know. Turkey, 2018, 1.4 kilos of californium 252. But please try to memorize. Californium is one of the most expensive elements. 1 gram is $25 to $30 million. And what is the amount of money for 1.4 kilos? It's really, really big amount. Suspected, and if you can see this $70 million price, I found this information on the internet, and if you calculate this 1 kilo and 1 gram, that's not something not normal, but everything depends on the purity, state of the agent, state of the element, etc. But never mind, it's a really big amount of money and really big threat for all the society. 4 people suspects were arrested in Ankara in Turkey. Thailand, 2021, 5 years ago, Thai authorities arrested some people who tried to sell 137 cesium radioactive elements before the transfer. And this is very interesting picture. This is a moisture density gauge. This is a very interesting device. This device, many people, workers, when they reconstruct roads and build new roads in many countries, use this device for measuring humidity in the soil. But for that activity, for that purpose, this device has radioactive element inside. And this is americium and cesium inside. But from my point of view, the main problem is if you found information that every year 50 devices reported are missing. Where is the device? They forgot in the gas station or supermarket this device. That's not real scenario. But because of the amount of radioactive element inside, type of the element inside, it could be a really big problem for the society, of course. I don't know, does the Italian institutes and companies use this type of device? It will be very interesting for me to know if you have any information, does they have these devices with radioactive elements. But the most important thing for you, my task for you, is to try to think about these possibilities, about specific radioactive elements inside some different things. I told you in chemical detector, and our colleague said yesterday recognized LCD chemical detector for chemical warfare agent with toxic industrial chemicals. produced from company Smith Detection from UK. Inside the detector is nickel 63 or similar radioactive source. Radioactive source in chemical detector. Because this radioactive source ionizes air constantly, and when you put air through instrument, we have separation of ions. We need radioactive elements for ion separation. And because of that, you are academic people, you know many things much better than me. Constantly think about the possibilities that you have a radioactive source inside. In many cases, you have small stamp, envelope, some paper, sticker, and described this type of element. This is the activity of the element. Each year, you need to send this instrument to laboratory for calibration, etc. But in many cases, you cannot find information that's radioactivity inside, like in this fire sensor. The CNT, maybe from the other side, but it's on the ceiling. You know, you will remove it and you will read it later. Just be careful because of that. How to respond to radiological event? First, we will identify presence. It's so easy, from Geiger-Miller counter to any modern device, semiconductors, etc. We can realize many different detection and identification of radioactivity. Isolate the area contained with different straps, with the types, with the flags, and do not enter inside. Protect everybody from contamination. Shelter in place according to that. In military, so easy. If you, for example, march and there is a nuclear explosion, you don't need to order anything. Every soldier fall down. Why? Just memorize the average surface area of one man, which height is 175 centimeters, 85 kilos approximately, is less than 1 meter, 0.75 square meters surface, while standing. But if he lays down at the ground, he's 6 times smaller, less the surface. And because of that, you need to be down to protect you from the blast. The blast is very harmful, you know, for everything, especially if the explosion is very big and very high. And provide needed immediate medical treatment. Pictures and original cards from 1999. This is very painful period for my country, because in that period there was a specific NATO intervention called, they called the NATO this intervention Merciful Angel, but 19 countries bombed my country. Activities last 77 days. Thousands of people died. It was very successful for something, unsuccessful for something. We can analyze it from military point of view, from the psychological point of view, from the political point of view, but contamination remains, radiological contamination remains. From the military point of view, we are happy because my country was the first which destroyed F-1016 Nighthawk invisible airplane and one F-15, etc. But many rockets from them killed many officers, many soldiers in my country, civilian people, hospitals, TV stations, etc., etc. Because of that, our task is to create network of CBRN professionals to live in peace, to help each other. During the old breaks, I discussed with many of you about need to be connected, to work fluently, to share information, knowledge. There is no need to hide, because now it's almost impossible to hide any kind of confidential information. During that activities, you can see this is Serbia, and Kosovo and Tokia is an integral part of my country. Many military units are there, and the NATO used A-10 aircraft with munition used from depleted uranium. You know, if you have nuclear material, the amazing way how to remove radioactive material from your country is through military technology. By ammunition, you go to another country and you place this ammunition somewhere. It's very powerful ammunition, you know, because of the density of that material. I found many vehicles, and penetrator from that ammunition goes through armored vehicle, through all vehicle, to floor of the vehicle, and 2 meters in soil. Here you can, and because of that, in the past period, we had many friends in NATO, even now, of course, it's normally, and many of them told us, now, for a few minutes, you will have a flight of these airplanes. The target is village this or school this school or some military object. And after, because of that information, immediately after the war, we started radiological decontamination of contaminated area. You here with this triangle, you will see all zones, all regions contaminated with depleted uranium. Now, what was the technology? It was so easy. First of all, you will use calibrated, you can see envelope marks detector, and you will put this detector on some stick. You will work in lines like you're finding the mines, anti-personnel or anti-tank mines, and then you find the response of the detector. You know that penetrator is there, machine is digging the ground, and after that, with big scissors, you collect. The team was consisted from experts from the Institute of Nuclear Sciences in Serbia, in my country, and military from personnel, all CBRN officers and the non-commissioned officers. And they realized this activity in many shifts during next several months, and we find thousands of penetrators. Now we place penetrators in specific objects under the ground, and we wait thousands and thousands of years, according to half time of the radioactive elements, etc. I have a question from you. This is original internet site. You can see investigation uranium contamination in Italian soldiers' deaths. Information from January 4th, 2001. Can you read it correctly, or I will read it to you? Okay, Italy has urged NATO to investigate the death of 6 Italian soldiers who died of leukemia after serving in the Balkans. Prime Minister Giuliano Amato believes that they may have died from contact with depleted uranium munitions used by NATO forces. There are many ways to die in combat, but exposure to depleted uranium is probably not one of them. Every year I asked someone, and everywhere I found some kind of silence. But once, during the one break a few years ago, one soldier came to me and said that his relative, who was a soldier, very healthy and young man, is alive now. He died soon after the mission in the Balkan. I know that many parents, families started the processes at the court. There are some refunding, and they especially soldiers from Germany, they pay them, maybe to pay them to share any information regarding that. But if you are exposed to depleted uranium, you will have many health problems. My question is for you: is it possible that this penetrator from depleted uranium that comes into direct contact with some water source under the soil? Yes. In this region, Kosovo, Metohija, we can say we have epidemic of cancer. Many people have problem regarding cancer, even small kids. That's not normal. What is the source of radiation? Food, water, air. I don't know. I'm not sure about it. This is very interesting table I prepared for you. This is a whole body absorbed dose described in grays according to different phases. First, immediate phase, latent period, illness, and mortality. You can see if you are exposed to doses more than 30 grays, all the symptoms very fast. Mortality is 100%, 1 to 2 days after the exposure. Because of that, in Chernobyl, all the firefighters and all the pilots of the helicopters died. Please try to find this Chernobyl movie, The Battle for Chernobyl. It's a wonderful movie because this very emotional attitude to people who are not alive anymore, just to be aware that radioactivity is a big problem for the society even now. Very interesting fact. If you need something for your preparation, for your study, you can use this table, of course. During next modules, you will use these softwares and many other softwares. This is one very interesting, a very famous emergency response guidebook, ERG. It's very easy to install on your computer and to realize different scenarios. For example, during the transport of chlorine, there was a car accident, 3 tons of material. What was the weather? Air temperature, what was the humidity, air speed, for example, everything you calculate and you measure what is the primary cloud and secondary cloud. Who will be affected? How many people will die for next 1 hour or a few hours? It's an excellent tool for prognosis of chemical situation. In the meantime, if you want, please type ERG, for example, and try to find many relevant information. We will have lectures about it, but it's very useful device. But even ERG, we have many, Aloha, we have S-Pro, many different softwares used worldwide for different purposes. Now, as a promise to you, you can see what is the next and final chapter for you. Time for a 15-minute break, and we speak about new trends, possibilities of application of different platforms and drones for in the area of civil and air and defense, etc. Thank you for your patience here. Please enjoy the break. Very interesting information. Don't try to get very complex. You will familiar my friend, collected information on putting international. Google contacted me, Ministry of Health in Italy. You know, I'm reason to stop. After
Someone. Human rights. I don't know, like the chemical.
Density of material is
I understand the reason behind this, but some NATO forces need to be compliant with the introduction of regulations.
That message
maybe I will have 30 minutes, maybe 30 minutes. Otherwise, even if it's a some sort of
I need to move your presentation here because I need my computer for work.
Nothing. No, there's no problem. Just do it. You know what to do.
Can you just give me the
USB.
yes?
Okay. To avoid transferring from this.
No. I have to close the call from here. Colomba, devo cambiare computer che mi riserva il mio per le call, va bene?
Ok, quando poi riassettate tutto facciamo di nuovo le prove di condivisione a sto
Sì,
punto.
mandami per favore il link su WhatsApp perché me lo sono impostato sull'altro computer.
Ah, ok, mo te lo mando di là.
Grazie.
Ciao.
Senti? Colomba.
Ready. Any challenge?
Quello ci senti?
Molto poco.
Molto poco.
È bassissimo il volume.
Aspetta. È sta tutto... Aspetta. Così?
Molto meglio.
Ok. Allora. Vedi lo schermo, no?
Sì.
Yes. For the end, I will tell you. Five countries. Okay, stop. Few of them. Okay. Yes, that's it.
Sì, questa.
Quello vedi e senti bene?
Sì, adesso sì.
Perfetto. Tanto non c'è nemmeno il microfono acceso, quindi dopo accende pure il microfono, va bene?
Ok. A vedere pure si vede bene, solo che... Aspetta. No, la modalità non è quella corretta, Andrea, devi cambiare la modalità.
Così?
Ok, adesso sì, va bene.
Ok.
Because last night, process. Yes, from 18 April to 1st May, 10 days, they made the non vedo il report sì.
Before the news. Che cosa? Che chiedete? Vengono messe tutto ormai. Alla fine di ogni settimana, l'inizio della settimana dopo viene messo a disposizione quello della settimana dopo.
Poi dall'inizio ci arriva il prima che mi sono
No, per quello va bene. Ma se serve qualche attestato di partecipazione, qualche attestato di ammissione, questi li possiamo fare. Insomma, Daniele, Dario sanno come la queste cose. Sì, quello lo dobbiamo caricare online qualche giorno. Diciamo che lunedì, martedì della settimana prossima dovrebbe essere già disponibile.
Però bisogna fare l'edizione, l'edizione di portare
Perché sono liberi,
about Beirut.
ma quando vi iscriverete vi sarà attivata una posta elettronica e con quella potete scaricare i servizi di Office per esempio di Stato civile per il funziona dalla settimana.
Spain was responsible.
anche quando viene rimasto, considera che noi stiamo mettendo online da quando è stato il studenti che hanno fatto lezioni da 19 20 hanno ancora quindi una volta che voi avete vi lasciamo, non vi togliamo magari vi serve per il lavoro, ognuno può accendere le sue masse a parte questo non ti
Guarda che lo stesso una giornata di disco.
I don't know. No, because I hear installation. For the installation, the files. I will check what is installed on the computer. If I have installation, it will be shared, you know.
Okay, okay.
Maybe I just have installation on computer without.
It's ERG 400.
That's it.
This is.
Maybe the.
Okay, it's
Now there is one more thing, you. You. So online you can see just, for example, city size of kilo.
Yes.
All
Okay. I use which is not. Okay. Because I'm working simulation. So,
come on.
non basta che fare. Thank you.
You're welcome. We'll communicate. Get my number. How do you tell you in the night? Midnight to G. Spaghetti recuperazione.
Preparation, spaghetti preparation.
Me la donna.
Preparazione. Yeah. Okay. Vabbè.
Okay, please take your seats. Maybe time for or poetry. Famous Italian poet. No, no. Maybe like. Please take your seats. Okay, according to plan of my presentation, now we'll speak about new trends, about CBRN contemporary devices used worldwide, about new challenges and risks for for us as a personnel, especially about new technical solutions. I presented you today application of drone. This is one, but please look carefully about this another application.
Well, what if there was a simpler way to assess the scene? Now you can take command of any situation from a safe distance. Meet the future of gas monitoring. The FLIR Move C360 is the industry's first multi-gas detector, fully integrated with an unmanned aerial system. Whether your mission is hazmat response, emergency management, environmental monitoring, or inspection and compliance, situational awareness is critical. Take command of any situation from a safe distance. With 8 sensors, including a PID, the C360 provides more coverage than a typical handheld gas meter. Powerful visuals from the ZenMuse XT2 combined with the C360 sensor data to give you a comprehensive overview of the scene. With the FLIR C360, operators can locate the source, define a safety perimeter, and monitor gas concentrations in 3 dimensions. And it allows responders to select the right PPE, monitor, analyze, log, and identify hazardous gases with the easy-to-understand visual overlay. Be the first in and the last out with the FLIR Move C360.
This is the first example. This is a small drone integrated with different chemical detectors. According to your needs, it's easy to obtain, to find many different appropriate small handy design chemical detectors or radiological detectors for that purpose. This is another detector with radiological detection, great with light identification. There is specific platform software, and in real time you have scanning area, detected objects, radiation levels. It's so easy to integrate this device with geography integration with system, spatial system, geoinformation system. Mainly to identify unknown place for radioactive source, to check suspicious vehicles. To perform high chromatography rates, for example, to identify specific isotope, cobalt-60 or cesium-137 or something else. This is very interesting. Nuvia company from Czech Republic I was there a few times during the presentation. We have an opportunity to buy for my military protects this device. It's very big, strong, many modules, many detectors, different types of detectors. It's not so expensive. Excellent ground protection. Wonderful. Very useful for many purposes according to your needs, according to your ideas. You can hide some small sources in cadets. Students will try to find the real positions, to identify them, the type of them. In this case, point radiation first. Visualization of Google Earth platform. According to our requests, we need direct reading and real-time transmission of all data in real time. There is no need to additional analysis in the laboratory after that. Very good device. What will be if your time is low inside? Combined, for example, with media source. And you can remember the
So the Merlin is a
another
small
platform.
tracked ground vehicle which can
Looks like
autonomously
toy.
navigate around
Maybe it's not.
obstacles.
The system on the robot, which is able to detect chemicals, is designed to detect chemical warfare agents which are deposited on the ground. When the robot identifies the chemical, it will immediately stop and raise the chemical detector from the ground and back off simultaneously. This allows the chemical detector to clear down and also for the robot not to cross that line of contamination.
The difficulty with chemical survey is it's a very burdensome task. It requires long hours in protected equipment and is hazardous.
So using a robot means that you can easily take the human team out of the hazardous area. During the trial, both human teams and the robot surveyed the same area. This allowed us to compare directly the results from both teams.
So the aim of the trial was twofold. It was to compare the performance of the robot with the human teams and also to allow the human teams to get hands-on with the robot.
Be able to see the robot being controlled by military users was great because that is what we were aiming to achieve.
It's very satisfying to see the military using it and becoming familiar with it.
It's such an important part of the job to be able to help military users to work in a safer environment.
Chemical detector on stick because it's easier to control the presence of agents in this position or to move your body to the ground.
Radovan, I'm sorry, you can go closer to the mic because we cannot hear your voice so well.
Okay. Is it better now? Can you hear me better now, Colombo?
And not so much.
Andrea is here. No, he was here, but he's
Just put your mic closer to your.
okay. Now,
No?
can you hear me now, Colombo?
Just you can go closer to the computer, please. and try again.
Now, can you hear me now?
Now it's perfect. Thank you.
Okay. Sorry, I don't like to sit, but for these needs, we have just more slides, few slides for presentation. Can you hear me correctly? Okay.
Yes, now yes.
Okay. Okay. Thank you, Columba. This is very interesting device intended for every responder, researcher, laboratory user. This is chameleon armband, very interesting elastic strap with different, you can see here 10 different cartridges. Each cartridge is intended for different agent. For example, for presence of sulfur, ammonia, and different chemical elements. You know, if this cartridge came into direct contact with some specific chemical, we have colorimetric reaction, changing the color. It's necessary to all the time to follow the changes on your hand, but it's very cheap and very useful according to your needs. In the other case, you will have the opportunity to use another chemical detector, another chemical process. In the case, if we have dead people, human corpse, it's necessary to be human in any way, you know, specifically in the hot climate, during the hot conditions, because of the composition and because of the biological process on the people. And it's just important to know, for example, the army, the military, and the first responder, they have answer for that. The solution for that is, for example, response store body storage system, mobile device. Just for a few minutes, you create mobile refrigerator integrated with compressor. You can see it here, and a human body will be inside in this chamber according to our needs, intention, and a professional approach. The future will be application and usage of different lethal autonomous weapon systems, but combined with artificial intelligence. You know, everything started with deep learning, and after that, machine learning during the 80s, during the 90s. Now we have artificial intelligence. We can say that it's a program which can sense, which can reason, act, and adapt. But invisible threat in the future, in the next period, will be application of different nanotechnology and artificial intelligence. Here you can see all challenges for CBRN defense. Now, if we speak about future 22nd century, for example, we need rapid detection as fast as we can do it, accurate identification of the all CBRN agents, effective response, but we know that we have limited resources in any case from the different point of view, and we have complex environment, mixture of, as I can say, RDD, radiological dispersal device, different biological agents, and you know that sometimes you need multi-specialist team to create to be ready for any kind of challenges. Just to focus on something so important, what is the future for us? Artificial intelligence powered sensors and monitoring systems. Why? Because they will obtain for us real-time monitoring, early warning systems for warning, and data analysis, which is very complex. But if we use all data and all experience from the past period on all libraries, the answer will be very correct. Now, you know that the main challenge, if you ask ChatGPT, Gemini, or some artificial intelligence program, and you know exactly what do you expect, there are many possibilities for mistakes made by artificial intelligence, you know, because now artificial intelligence need human approach for filling the data, for inserting all information inside, and many times it's possible that someone insert mistakes, and this data is not real and not good. And because of that, data analysis is so important for us. Predictive analytics for threat detection is something which is so essential for us. I discussed with many of you during the break about different softwares for that. We have many of them: MVC analysis, Aloha, ERG emergency response guide, we have HAS Pro, we have many nuke for nuclear analytics. That's so important for us to know. All historical data, all real-time data important for us, predictive algorithms, models, and early intercooperation. Autonomous decontamination and response is also important for us. I hope, and we really have an idea to use robots whenever we can instead of people. Human life is so precious for us. I showed you yesterday this morph robot like dog, mannequin of the dog. It's expensive. I told you 300,000 euros or dollars, but it's much cheaper than human life. But according to artificial intelligence and according to all sophisticated characteristics, now it's possible to create all modern contemporary detection and analysis. Yesterday you saw the analysis of fentanyl as a possible contaminant. Remote control also visible yesterday at the movie, and the final result is risk reduction. Training and simulation with AI is very important. Now, at the end of my presentation, it's mandatory to say that training is everything. Our mission is to realize enough basic educations, classroom lectures, but also practical sessions, training, tabletop exercises, and finally, maybe I really believe that many of you will participate to different live agent training, firstly with simulants, later with real chemical, biological, or radiological agents. Scenario-based training techniques are very different. Now we can simulate very different simulations. We call it maze exercises. For example, for many trainings in my country, we realize scenario, for example, some restaurant with different chairs, tables, and many bottles with water, unknown chemicals, something different gloves next to the plastic materials, and it's big task and big challenge for instructor to train people and people to, as a trainee, to realize final exercise, because somebody will follow how they work, how they detect, how they realize procedures, how to stay safe in contaminated area. And because of the artificial intelligence, it's so easy to create real scenario-based techniques. And AI-driven simulations for readiness, it's also very important for us. We don't have this simulation connected with AI, but I know that in Germany and the United States, my friends visited some laboratories. They show me that they have very nice simulation prepared with artificial intelligence. The most important thing regarding artificial intelligence is that artificial intelligence driver decision making in emergencies. To make decision is many cases is very difficult. And how you can be sure that your decision is right decision. First of all, we need to collect all relevant information. That means data collection, all relevant data from different sources as soon as possible. Second analysis phase, utilize artificial intelligence to analyze data for patterns and risks. Risk assessment, you will evaluate all risks. Now we can use and you will use different softwares for that, but with the assistance of artificial intelligence, you can probably use these opportunities much better and quicker. You will identify all CBRN threats. Next phase, number 4, action planning. And our task will be to develop strategic response plans based on analysis. And final, last chance, last phase, implementation. That means execution of plans and monitoring of outcomes continuously. Here you can see some steps, how to enhance CBR response with artificial intelligence. We don't have some standard regarding European Union Commission about that. It's early, but I really strongly believe that in next period, few years, we will have very unified document for European Union regarding enhancing CBRN response for global strategy, national policies, local initiatives, training programs. It's vital for that. data analysis and operational tools. The future of artificial intelligence and in CBRN defense depends on many, many factors. What do you think? What is the main factor which has a very important role in CBRN defense regarding artificial intelligence? Yes, prevention, of course. What about our possibilities? We know anything. It's possible to find any many relevant information regarding chemical, biological, radiological, nuclear threats. Okay, we have support from artificial intelligence, but not this type of Gemini or ChatGPT. It's for civilian purposes. It's for us. It's also a big problem, hacking activities, sensitive information from cloud, for example. Now we have very interesting approach in many, many countries. IoT, Internet of Things. You probably heard about it. And you have very interesting topics regarding Internet of Things in medicine, in public health. All sensitive information regarding health status of every people, every man, every woman, every child are somewhere integrated in some kind of cloud as a sensitive data. And it's very easy to manipulate with data. It's because of that, your reference protection is on the first place. What do you think? What is else? What else is possible to problem or something for discussion regarding the future of AI in CBRN defense? Yes, as I said, yes. And intentionally or unintentionally? Intentionally. To create a mess to some. But it's more important to know that all softwares, ChatGPT or Gemini and many others for creation of pictures, videos now, news, etc. The government, military forces, they have much better softwares and much better basis for that, because it's a very big challenge. You know that for example, the internet, for example, internet as a way of communication started first time in the military. All new technologies started firstly in military, and if you are satisfied with your internet, your interface for communication, your mails, your etc., just think what is the approach in the military or some very rich country. They have something different, something better, with better possibilities and characteristics. And what do you think else about influences of any other factors like protection, like sensitivity in the way of artificial intelligence and CBRN? Communication and psychological point of view is also very important. But what do you think about lessons learned? If you have some accident in your country, you know consequences. Okay, will you create some comprehensive report and publish this report on the internet to be available on some platform and widely used for many countries? What do you think about? Is it normal approach, or it's necessary to reconstruct the report to hide some relevant and very important information from others? But it's possible scenario, yes? Real scenario. At the end of this presentation, we have enough time for questions, but please, at the end, you know that my initial plan was to finalize as soon as possible this lecture before the lunch break, and Andrea asked me to finalize it on this way. I'm very satisfied, and thanks to Andrea, I had a chance to speak much more with you. Thank you for your patience. Thank you for your energy, positive approach. There are no energetic vampires, as I saw in this classroom. I'm ready firstly for your questions now. I'm ready for any type of cooperation with you. As I said, the presentation is on the desktop ready for your download. Second slide is slide with my telephone number. You can contact me by Viber, WhatsApp, the both widely used applications. You have my Gmail email. If you have questions, every year, many people contacted me about some opinions regarding different aspects in the CBRN. And because of that, I'm offering it to you to help you to publish if you want something with you, to propose you, for example, some interesting chapter, topic, idea for your master thesis, for example. One participant told me from Portugal that he knows Adolf Eid, who was a student of the first level in 2018. And now we are really big friends. He's from Lebanon, now lives in Cyprus. And he finalized first level here. And he was an excellent student. And he finalized also second level, but it was in the COVID pandemic online system. Now his proposal was to work with me. Andrea, professor, gave me full freedom to create very interesting topic for him. And believe it or not, his topic for the second level was application of depleted uranium for different purposes, etc., etc. And I gave him many information about the concept, how we realize these activities of radiological decontamination in specific zones, about health risk, about procedures, etc., etc., etc. And if you want, this is just the beginning. My role was to introduce you with the basic CBRN terminology, factors, about definitions, some classifications, etc. Week by week, module by module, we'll be ready for new challenges. Maybe Professor Andrea will invite me again to participate. As I told you, I started 9 years ago with 16 hours of classes. Now I had 7, but we multiplied with prolonged plus 2 hours. I need much more time to speak with you about very important facts regarding protection, respiratory protection, body protection, CBRN decontamination, CBRN detection and identification of the all agents, etc. I really have, if I can say, big experience from laboratory and field exercises and sampling, and really I'm instructor for the OPC courses for basic and on basic and advanced levels in CBRN Training Center and Institute Vinci for different trainees from Kuwait, from Saudi Arabia, United Arab Emirates every year. And because of that, it's very big challenge, excellent challenge for me to work with different nations, religions, to share knowledge. But my final word for you is, let's be professionals, let's share all knowledge, let's create a very interesting, very nice, a very useful CBRN network, and try to find a way for future, for the next collaboration. That was all for me, and thank you. This uploads will be recorded on the. Thank you for that. Do you have any specific questions regarding information? I hope that I prepared it.
Radovan, they have a questions. The students connected by United Arab Emirates. They have a question about the what type of gamma detector used on the drone that you showed in the last slide.
We will check it now. Sorry, the exact type of gamma detector.
Yes, they asked for it.
Just to check.
So please, Umahid, if you want to open your mic, you can do it.
I will prepare it information during the break and send it to your WhatsApp as a message and give it to you directly. Don't worry.
Excuse me, sir.
Yes.
This is Muhammad Al Abduli from United Arab Emirates as well. I just had fun. It was very nice lecture. I just have one comment on the AI because it was so interesting idea. I believe in the future they will use the AI in the chemical or CBRN field. However, it's very difficult right now because, as you mentioned, it need a very large database. But I believe it will be very useful, especially in the prediction of CBRN, the duration, how long it will stay, and I think also it will be very useful in the command and control also, because it could provide the people who's working in this field the necessary information to finish the job in the best way. That's my comment in the AI, and I hope they will approach it soon, but I'm not sure about it. Thank you.
Yes, it's very good idea. And for example, I have one project with my students. It's project of Horizon and the European Union project. We build a new CBRN drone for chemical decontamination now, because there is no other drone for decontamination purposes. This is some kind of modification of agricultural drone. I showed you the agricultural drone movie from China, DJI company, but we have a specific needs, and we build in the past period this drone for chemical, biological, radiological decontamination with specific decontamination compounds. It's also very interesting idea, and it's possible to combine it with artificial intelligence on any way.
Yes, it is very interesting idea. I think the main problem using drones is maybe the capacity of the tank, and I hope that you will do it soon.
Yes, we already realized this project because the capacity is very big. We have 20-25 liters canister, and it's just enough if you want to decontaminate one tank, one aircraft, helicopter, or something else.
Hi, Doctor. Thanks for your lecture. We get very high value information and knowledge.
Thank you for that.
And I want to share with some of my experience. I work already with AI on identify some chemical compound and OPCW presented before 2 years. The challenge was using the AI to solve the challenge itself. So it helped us to solve it faster than if we not use the AI. But the challenge in the AI is, as you know, is the data center. Without a huge data
very
center,
sensitive. Yes, very sensitive. Yes.
Yes, because without the data center, you cannot. It will be very lag.
Absolutely.
And as you know, it's need a lot of training and scenario to build the data center for the AI. On the other hand, for the drones, I think we already saw some drones with nuclear detector just for the mapping. But the issue it was the contaminated. If the drone is contaminated, so it's very hard to decontaminate it, and it may cause cross contamination, as you know.
Yes, yes.
So that was the challenge.
But it's possible to protect your drone from vital part of the drone from possible contamination.
Yes, but we was working what if it is like chemical, where some of people using like chemical warfare agent and have a very very big
Yes, many
contaminated
parts of the
area.
drone are very sensitive to the contaminants because of
Yes.
the electric parts, etc. You need to avoid some contamination of the elements and destruction of that. Yes.
And on the other hand is the big issue for the drone, as you know, is the payload. So
Absolutely.
sometimes we cannot use multiple sensors or detectors because of the payload.
Yes. Yes, excellent comment, excellent opinion. Satisfied with it. Thank you.
You're welcome, sir.
Okay. Thank you, Colomba.
You're welcome,
Yeah.
Radovan.
Thank you, and see you soon. I have a questions. I have the questions from Saudi. From now it's confirmed. It's sent.
Colomba, io
Dimmi.
aspetto polizia.
Sì,
Guys, good news and the bad news. The good news is tomorrow afternoon we are at the Faculty of Engineering in a very big and fancy room. Okay. The bad news that tomorrow morning is confirmed the room